Hi class, so we are moving on here to 8.1. Hopefully you can hear me okay. Alright, so looks good. So we're going to be doing with two more formulas in this section. One's called the law of sines and one's called the area formula. So we'll learn an area formula as well, and we'll learn law of sines. So we'll have two types of formulas we're going to learn. Okay, the first thing is the law of sines. Now, what we are going to be learning only applies to triangles which are non-right triangles. So back in chapter 7 and 6 and 5, all the formulas that we learned for sine and cosine, like SOHCAHTOA, SOHCAHTOA, all those things, okay, only applies for right triangles. Okay, so we had to have a triangle with a right angle, because that's what, if you have a right angle, that's what means that tells you have a hypotenuse. You don't have a hypotenuse for a non-right triangle. Okay, so hypotenuse and legs only appear for a right triangle. But that's really boring. What if we want something besides a right triangle? Well, those are called oblique triangles. It just means not a right angle, so not a right triangle. And so those don't have, say this is 40, 60, and 80 or something like that. None of those angles are 90 degrees, and so this is a non-right triangle. So it's called an oblique triangle. So this triangle doesn't have a right angle. It means it doesn't have hypotenuse. It doesn't have legs either. We just have what we would call the sides of the triangle. Now we can still use sine and cosine and all those things. We just have to use them in a different way. So we can't say sine is equal to opposite over hypotenuse. But what we can say is that if you have a triangle, so say like for this one right here, we have angle B, angle C, angle A, and call this side A and side C. What the law of sines says is this. It says sine of A, so sine of this angle divided by that. So for this problem, it would be sine of 50 over 10. So notice that this it works opposite. So the angles go opposite with the side. So big A, the angle big A goes with this side, little a. So these are across from each other. They're not touching. So anyway, sine of 50 over 10, according to this formula, is the same thing as, say, sine of, I don't know, 30. Here's 30, and over its side, like that. Okay, so that's what we mean by the sine law, is that if you have sides A, B, and C, and then you have the angles big A, big B, big C, where they're opposite, they're not touching the side, then we can apply these ratios. And they work anyway. See, notice here that I did the sine A equals the sine C. And that's what this law is saying. It's saying that you can use any of these three. So any of these work. So you could say sine A equals sine C, or sine A equals sine B, or sine C equals sine B, or sine B equals sine C. It doesn't matter. In this case, I did A equals C. Now what's cool about that is that allows us to then go ahead and solve for this unknown side. And you just cross multiply, and you get C times sine 50 is equal to 10 times sine 30. And then you divide by sine 50. Divide by sine 50. And you get little c, the side here, is equal to 10 sine 30 divided by sine 50. Okay? And then we'll just use our calculator to find that answer. So jump right to here. So 10 sine 30 degrees. Oh, let me make sure. Hold on. Let me clear that. make sure. So this problem is in degrees, so let's make sure we're in degrees. Okay, I am good. So 10 sine 30 divided by sine 50. There you go. So I found the psi was roughly equal to 6.53. So 6.53. Okay. And then we can do the same thing. We can do the same thing to find b. All right. So let's go ahead and finish this triangle, and then I need to go back and talk about the two cases here. We'll go through all of them, but just I want to finish this problem up since we've been talking about the formula. So we have little c we found out, and now we got to find, we can find the angle too for b. So if I know two of the angles, I know this angle because this is 50 plus 30, so b has to equal 100 because 50 plus 30 plus b has to equal 180, and so b has to equal 100. So why don't we use that sine b law to do this? I'm going to have to use some of this room up here. So sine b, so sine of 100, over the unknown side, which is opposite over here. It goes right there. Over sine b, or b, sorry, is going to equal, and we can use any of the things that we did. Why don't we just do a? So it would be sine of 100, a was 50, little a is 10. Okay, and then the same thing, just cross multiply and do that algebra, and what you get is that b is going to equal 10 sine 100 divided by sine 50. Okay, and then again we just go to our calculator and do that. So that was 10 sine 100 divided by sine 50. So 10 sine 100 divided by sine 50. 12.86. So b is equal to 12.86. Equal 12.86. Okay, so we've solved that triangle now. So now we know all the angles, all the sides. We know a is 50, b is 100, c, these are all degrees, is equal to 30, and we know little a was 10, little b was 12.86 roughly, and little c was equal to 6.53. Okay, that's what we mean by solving a triangle. Remember, solving means that you find out all the sides and the angles. Okay, all right, so that is the simple case when we have ASA or SAA. So remember that from geometry, that means we have angle, side angle, or side angle, angle. So in this case we had, what did we have? We had side angle, angle, so side angle, angle, because we had a side given to us and we had an angle and an angle. So that's meant that we had this case. That's one unique solution. Now we got to be careful when we have this case. This is called the ambiguous case, when you have side, side angle. So it's side, side angle. So when it's ASA or SAA, this is pretty straightforward. So that is the easy case. There's only one solution. When we have this other case, the side, side angle, okay, you have two sides given to you in a problem and only one angle. That's going to be ambiguous because sometimes we're going to have one solution, two solutions, and we'll see. So just be careful when you see two sides and only one angle. We're going to be in trouble, and we have to make sure we have to be very careful what we do here. Okay, so I always tell my students, you know, when you have this situation, be scared. Okay, so don't be anyways. So when we have SSA or ASS, okay, we don't want to assume, I'm assuming person. Okay, I got you there. You don't want to assume that you get the answer, so let's be careful, okay? But anyways, we're going to be working on these cases is when it's a not a right triangle. So we're not going to have a right angle, but we're going to have two sides and one angle. So this is the SSA case because I have two sides and I have one angle. So what that means is that we're going to have a little bit of trouble here, and we just got to make sure that we do it right, okay? So let's take a look. This is going to have one solution, and let's see why. So first of all, let me identify stuff. So this is little a. Let me call this big A. And I get to choose. So I'll just call this. I'll call this B, I guess. And I'll call that big B. Okay. And I'll call this big C. And I'll call that little c. Remember, angles always have capital letters. The sides are the lowercase. Okay. So A we don't know. So question mark. And we also don't know the angle B or the angle triple. Okay, so what we can do is we can still set up one of our sine laws. And so I'm thinking sine 85 over its opposite side. So sine 85 over its opposite side. Okay. That has to equal. Now we can choose. I'm thinking of choosing this one of the B here because that's going to go right there. I know this side, so it's going to be sine of B over 9, like that. And so this allows us to then solve for sine B, and so we just cross multiply, and you get 9 sine 85 divided by 12 is going to equal sine B. Okay, so now we want to solve for that angle B, and all we do is we just take sine inverse, because sine inverse cancels out the sine. And so I just take sine inverse of that thingy, okay, and we'll get the angle B is just equal to sine inverse of this entire thing. 9 sine 85 over 12. Okay, so we go to our calculator here, find that. And we get, I'm going to do the inside first, so I'll do 9 times sine of 85 divided by 12, and then I'm going to take sine inverse of that. Sine inverse of that, and we get 48.34 degrees. So so that tells me right here that this angle is 48.34 degrees. Right there. Didn't really leave enough room on this problem. Apologize for that. So anyways, so that's B. And now that we know B and C, we can figure out A, okay, because, you know, A plus 85 plus 48.34 has to add up to equal 180, and so that's going to be 180, take away, so A is 46.66, okay, so that's 46.66. Okay, so I found that. I already know big C, and I just need to find this one, the leftover side. And to do that, what I'm going to do there is I'm going to go ahead and find that side. But before I do that, before I find that side, let me tell you why there's only going to be one solution here. Okay? It all comes down to you need to add up all the angles. So if I add up all the angles, all you simply do is let's take a look. So all you do is you take your answer from this one, which was 48.34, okay, and what you want to do is take it away from 180, and so let me show you how. So take this answer from the answer that we got right here. Okay, so before we did this was just adding, but before we go back over here, so we take this away from 180, so do 180 take away b, which was b, 180 minus 48.34, so 180 minus 48.34, 131.66, okay. All right. And now all you have to care about is then, is this going to be bigger than 90 or not? Because if it's bigger than 90, then it's going to be another one solution. So this is bigger than 90 degrees. Okay. And so that means that we only have one solution. That is the check. That's all you have to do. Okay? So if this number is bigger than 90, then we're going to have one solution. So in other words, so let me write that as a summary then. So an even faster way to check is that if the angle, so I called it B here, right? If the angle is that you found from here, so let me just call this angle right here. If the angle is less than 90, then there's only going to be one solution. And we're good to go. Okay? So we're good to go. The angle we found was less than 90 degrees, and so that only gives us one solution. And then we found this angle, and then let's go ahead and find the last side, find A. So you might want to write that as in a box. Okay, that's the way you tell if there's only one solution. We're going to do a case where there's two solutions down here, and we'll see what happens. All right, so last bit, let's find the last side. So I know that sine of 85 over 12 is going to have to equal the A one, so sine of 46.66 over the unknown. And so that tells me A cross multiply, A is equal to 12 sine 46.66 over sine 85. Okay, and so then you go here, 12 sine 46.66 divided by sine 85. Okay, and that gives me my last side, 8.76. And so that's right here, 8.76. Okay. All right. So that's just when we just had the single case. All right. So we can go ahead and also do the. I want to show you. Sometimes we're going to get two solutions. I really wish I had left a little more space here, but maybe I'll work through the first solution and just show you why there's a second solution, and then leave the rest for later. So Again, the first thing you want to do is first just check, is this an ASS or is this an ASA? So I have two sides here, so I don't want to assume. I'm not an assuming person here, okay, that there's only one solution. All right, so there might be two, or it might be zero. And the way you tell, again, is that I only have two sides and I only have one angle. So that's kind of the giveaway. If you only have one angle, then you're going to be kind of in trouble. So 6 and 8. Okay, so what should we do? Well, I think let's first label stuff. So, you first want to label everything so you kind of have something to refer back to. So I'm thinking I want to refer this to be called big angle C. It's completely arbitrary. I'm just labeling them. Okay, which means this is little b, this is little a, and this is little c, which is unknown. Okay, and again, this is a non-right triangle, I hope. They didn't say that there's a right angle here, so this tells me that I'm going to have I use law of sines here. So probably the first thing we want to do is find one of the angles B or C. So let's see, and remember these go here and that goes there. So let's say sine of 35 divided by A, which is 6, has to equal sine of B divided by 8. Okay, and then you cross multiply and you get sine of B is equal to 8 sine 35 divided by 6, and then again you just take sine inverse, and so you have sine inverse of 8 sine 35 divided by 6. Okay, and then we're just going to go ahead and jump to the calculator here. So we have 8, again I'm going to do the inside first, so 8 sine 35 divided by 6, and then you take sine inverse of that. Okay, and so that's 49 degrees, and so we get B is equal to 49 point 9, what was it, 0.9, 0.9. Okay, alright, so here's the check. What you want to do is you want to take this answer, it's called B, and you want to take it away from 180. So here's the check. You do 180, take away your answer, 49.9, and that's going to be equal to 130.1, I think, like that. Okay. And then what you do is you then, okay, so this is 130.1. So then what you do, the last step is you just then say, okay, do 180, take away 130.1, okay, take away the original angle, 35 degrees. And that's going to equal 14.9 degrees. Okay. So that's positive. So what that tells me is that the other angle could be 14.9 rather than just to find out what's going on. So the problem with these triangles is that I found out that this could be 14.9, okay, and I found out that this could be 49.9 degrees, okay. The problem is that it could also be, ooh, I could also have another triangle like that, where this is 35 degrees, this is still 49.9 degrees, and this one was the the other angle, which was 180. Take away 35, take away 49.9, which was the answer here, which is equal to 95.1. Okay? So this is what we call the ambiguous case, where I have two possible answers: 14.9, 35 degrees, 49.9, or 35 degrees, 49.9 degrees, and 95.1. So, anyways, on the homework, they're going to guide you through to make sure that you check for this. Okay, for me, because it is students usually have a tough time with it. I'm not going to give you one of these cases on an exam. Okay, it also just takes a lot of work. So the ones we're going to do is going to be the non-ambiguous case. Sorry, it's going to be this case where it's it works out to be fine. Okay. So, but let's just go ahead and get through this so you can still work through this on the homework and stuff. So last little bit, so this is 49.9 degrees, and then we can go ahead and solve for the sides. I'm going to set up maybe solving for a side, but maybe not do all of them, because again, it's just applying the law of sines. So let's look at triangle 1. I'll call this triangle 1. If we look at that triangle, then what we have is, say we want to find side C. So that would be sine, so that one goes with that one, sine of 14.9 degrees divided by its unknown side. That has to equal, you can choose sine of 35 degrees over 6. And then you just cross multiply, and you get 6 sine 14.9 divided by sine 35. Is equal to C. And then we just plug and chug on our calculator. 6 sine 14.9 divided by sine 35, which would be 2.69. And that will go right here. So that's for that triangle. But if we have this other version of the triangle, again, there are two versions of it, then this is still 6, this is still 8. Watch what happens. So that's for triangle 1. For triangle 2, we can do the same thing. We have sine of 95.1 over the other side, the C. So over C is equal to sine of 35 over 6. And when you do that, you get C is equal to sine 6 sine 95.1 divided by sine 35. And we plug in there 6 sine 95.1 divided by sine 35 equals 10.42. So we have two options for C now, 10.42. So that goes right here. So we get a different answer because there's two different cases. Okay, now I think maybe I didn't explain that super well, so just look on the homework. There's going to be tutorials to help you solve for when you know it's going to be one solution or two solutions. The last case, though, is when we have no solution, and just because I can write a triangle out doesn't mean it actually exists. So here, It says find a triangle with a side length of 4. Okay, so I'm just going to draw a triangle. I don't know what it looks like. And it says side length of 4, so I call that 4. It says the opposite angle of that is 50. And the second side has length 10. Now see, it says the second side. Well, I don't know which side it is. I don't know if it's that side or that side, but let's just see. Let's try to draw like a 10 here. Okay. So call that big A, call this little a, and call that big B, call that little b. Let's see what happens. So if I write this out, try to do sine law, so this will be little c unknown, and I don't know c, the angle. So if I do that, then what do I get? So let's try sine law. So it's going to be sine of 50 over its opposite side over 4 is going to equal sine of b over its side, which is 10. Remember, these go here and here. Okay, so then you cross multiply and you're left with 10 sine 50 divided by 4 is going to equal sine b. And then you take sine inverse of both sides. Okay, do not know what just happened. Undo that. Okay, sorry, again, as for the whole semester, my Microsoft Word is messing up, but hopefully we'll get through this last video, and we have one more video. Hopefully I'll do that before my computer completely bites the dust. Anyways, we make do with what we can. So now what we have is b is equal to sine inverse of 10 sine 50 divided by 4. Okay, let me show you what that is. So I have b is equal to sine inverse of, let's show that on the calculator. So we're going to have 10 sine 50 divided by 4, 1.915. So hopefully some of you might already be seeing what the problem is. This is asking us to take sine inverse of a number bigger than 1. So this is asking what angle makes sine produce 1.915, but we know that that's out of bounds. And we can try to get an answer here, and it's going to say undefined domain. Okay. So there's no answer there. All right. So there's no solution. There is no angle that makes sine bigger than 1. Okay, sine, the biggest sine can get is 1 or negative 1. The smallest it can get is negative 1. So that means that there's no solution. So there's no triangle. So all possible triangles, so there is no triangle. Just like this. Okay? Alright, so that's it. So that's it for law of sines. I do want to do one more formula for you. Okay? And then I want to actually do some word problems with this. So the last formula we're going to learn for this section is what's called the sine area formula. So what that says is that back in the day we learned the formula for area of a triangle is equal 1/2 base times height. But that's if you know what the base and the height are. If you don't know the base and the height, there's another formula which is called the area is equal to 1/2 AB sine C. Okay? A and B are just any legs on the triangle. Not legs, sorry, any sides of the triangle. It might not be a right triangle. Okay? This works for any triangle now. Okay? Any triangle. So any non-right triangle. if you have two sides, then you have the angle in between. So that's the key thing. C has to be in the angle in between. The sides, A and B. If you have that, so that's big angle C, then the formula is just 1/2 AB sine C. And so for this problem, Rochelle's house is on a corner lot. She has the area of her front yard. She wants to find the area of her front yard. She measures 40 feet on one side of her yard and 56 feet on the other. The angle in between is 135, so the area is simply going to be really quick way to find out. It's just area is equal to 1/2 40 times 56 times sine of the angle in between 135. So that's pretty rad because it's not always you're going to be able to figure out what the base and the height are for a triangle. It's a lot of times it's easier just to measure the sides and then just take a protractor or a compass to find the angle in between. So this is going to be 20. So this is going to be 20 times 56 times sine 135. 135. We can go ahead and use that on our calculator. So we have, 20 times 56 times sine 135. And so you get 791.96. Okay, and I'll say 791.96, and I'll say what, chickens? No, we say that, okay, she's talking about feet, so it's going to be, and it's an area, so it's going to be feet squared. Okay, so pretty simple formula to know. Just the only thing that people have trouble with is that you have to understand that that C, okay, that C has to be the angle in between the sides. Okay, that's called the included angle. I put it in bold here, hopefully it sticks for you. Okay, so we're going to move on. I just want to do two application problems here. So go ahead and read example 6. Try to come up with an idea of what you think the picture is. Go ahead and hit pause. Try to draw the picture that you think of what's going on. And then we'll come back and I'll have my picture done. Okay, and we're back. So this is the picture I drew. Make sure the volume works, okay? And so we have 15 degrees here, 35 degrees, 20 miles in between them. What do we want to find? We want to find the altitude, which means that we actually want to find this. So we'll call that a height. So that's the altitude of the aircraft, how tall it is. So let's just go ahead and start plugging and chugging. I'm thinking that since I dropped this altitude, that makes a right angle. So if I can figure out maybe like this A as the hypotenuse of this triangle, then I can figure out what this length is as well. Okay. So to do that though, in the triangle, in this triangle, so call that big angle A. In this triangle, I don't really have a right triangle in this bigger triangle out here. Okay, this is an oblique triangle, so I think I'm going to use law of sines for that. So sine of 35 over the opposite side, so that goes, talking to that guy, over A, that has to equal sine of, now I want to use this side, 20, okay, because then I can, I know this side. I don't know this side over here. This is unknown. Do I know this angle right here? Call that. I do, because 15 plus 35 plus that has to equal 180. So let's call that angle C here. So I know that C plus 15 plus 35 has to equal 180, which means that C is equal to 180, take away 50, so C is equal to 130. And so I know my angle now is 130. Alright, again, cross multiply, and you get A is equal to 20 sine 35 divided by sine 130. And we'll go ahead and use our calculator. 20, 20 sine 35 divided by sine 130. Again, those are non-standard angles, so there's nothing we can do except use our calculator. So 14.98. And those are miles. All right, so I figured out that this is 14.98. How's that going to help? Well, now let's take a look at this triangle. So now I have so now I have an angle here, and I have the hypotenuse. So remember, this is a hypotenuse now in this triangle. Let me draw it in red here. So now I'm looking at that triangle. So now I have I have an angle, I have hypotenuse, and I want to know the opposite. So this is a right triangle now, so I can use sine. Okay, I couldn't use, like SOHCAHTOA before, but now I can because I want opposite over hypotenuse, so that's sine. So sine of 15 degrees is going to be equal to opposite, the unknown, so I'll call that h, or just h over the hypotenuse, which was 14.98. And so that tells me h is equal to 14.98 times sine of 15. And so that tells me h is equal to 14.98 times sine of 15. It's 3.88 miles. Okay. All right. So that is that one. All right. And I want you to pause the video again and take a look at this last one here. Go ahead and pause it, try to draw a picture, see if it matches what we have, and then we'll come back. I'll have my picture, and then we'll work on it. Okay, and we're back. So this is the picture I came up with. So this is the tower right here. This is Coit Tower. And I measured from here. I started here, and I measured the angle was 39. Remember, elevation means that you're going up, so 39 degrees. And then I moved 83 feet closer. And as I moved 83 feet closer, I measured the elevation again. It was 50 degrees. So, and the other thing is that, so this part of the triangle is 83 feet. That's what I measured. Okay. And yeah. So how was I able to figure out 130? So 130 wasn't given in the problem. Well, remember, if this angle was 50, 50 plus this angle has to add up to be 180. So that's why that's 130, because 50 plus 130 is 180. It's on flat land. Okay, so that was 130. That's how I was able to find that. And since I know that's 130, and I know this is 39, I can figure out this angle too. So that angle was this plus this has to add up to equal 180, and so you take it away from 180, and you get 11 degrees. Okay, and you can check, because 11 plus 39 is 50, 50 plus 130 is 180. So that tells me why those angles worked out to be that way. Okay, so then I know that. Let's measure. I want to find out how tall I can estimate the tower to be, and it looks like it's going to be just simple using law of sines here. Okay, I'm thinking like this: if I do sine of 11, okay, over the side 83. That's the same thing as sine of 39 degrees over this side. So let me call that big angle C. This will be little side C. So I'll call that C. So then if you cross multiply, then you get C is equal to 83 sine 39, excuse me, divided by sine of 11. And then we just plug and chug in our calculator. It's 83 sine 39 divided by sine of 11. It's 273.75. So C equals 273.75 feet. Okay, that's going to help me because now if I look at this triangle, try to do it in blue here. So if I take a look at that triangle now, I'll draw it again. I have a right angle. This is the tower. So I'll call this height. And I know this angle's 50. I know the hypotenuse now is 273.75. So again, I have a right triangle now. Before I didn't. And this other triangle, that was not a right triangle. But this is a right triangle, so I can use SOHCAHTOA here. So I'm thinking if I have an angle, I want the opposite, and I have the hypotenuse, that's sine. So that's going to be sine of 273, sorry, sine of the angle, sine of 50 equals opposite, so h over hypotenuse, which is 273.75. And so that tells me just move it over, so you have 273.75 times sine of 50. And that tells me I get 273.75 times sine of 50, 209.7. So I find out the height is about roughly equal to 209.7 feet. And I did check on Wikipedia. That's like really close to what the actual height of the Coit Tower is. I think the actual tower is like 210 feet. So I was pretty close just from measuring that out. So you can see that trig is pretty good. I was a little off probably because when I was measuring, I might not have walked exactly 83 feet. I might have walked like 82.2 feet or something like that. Just using the GPS on my phone. And the angles could be a little off too. I might have actually been more accurate if I had said like 39.2 degrees or whatever. Okay, so I hope that helps, and we have one more video, and catch you next time.